Good evening, everyone. In the last session, we were discussing about electrolysis of the molten as well as aqueous substances. So it's a continuation of electrolysis of aqueous substances. Electrolysis of aqueous substances, because in aqueous substance it means it contains water, and the aqueous substances are divided into two categories. One is known as concentrated, another one is dilute. So when we say we have a concentrated solution, what does it mean? It means we will have more electrolyte or more salt, and we will have less water in it. And when we say we have a dilute solution, it means we have less salt and we are having more water. That's the meaning of dilute aqueous solutions. So during electrolysis, the positive ions are attracted towards the cathode. So the positive ion, which is less reactive or it does not react easily, so the positive ion which is less reactive is discharged, or we can say collected at cathode. So you have to remember the reactivity series. So during electrolysis, the positive ions are attracted towards the cathode, but the positive ion which is less reactive is discharged at cathode. So you will always, whenever you're comparing, you should remember the reactivity series for positive ion. And during electrolysis, the negative ions are attracted towards anode, but the negative ion, which is more in the solution, is discharged at anode. Discharge means collected. It's the same meaning if I say use the term discharge or I say it is collected at anode or cathode. Discharge is a scientific term which is used for these ions when they are collected at anode or cathode. So the negative ion which is more in the solution is discharged at anode. Except three ions does not move because of their size: sulfate, nitrate, and carbonates. Even they are more in the solution, sulfate, nitrate, or carbonate, they are never discharged at anode. So for electrolysis of aqueous solutions, we have to check, for positive ion we have to check the reactivity, and for negative ion we have to check the amount. So example, we have aqueous concentrated sodium chloride. That is also known as brine. This is a name given to a concentrated salt solution, sodium chloride solution, also known as brine. So what are the ions present? Because we say it is aqueous concentrated, so it contains sodium ion, it contains chloride ion, and it is aqueous, so it contains hydrogen ion, and it also has OH ion. Because it is a concentrated solution, so we'll have more salt and we will have less water. As mentioned, it's an aqueous concentrated sodium chloride. Now the electrolytic cell, which consists of anode and cathode made up of either graphite or platinum. The meaning of brine: brine is a common name which is used for concentrated sodium chloride solution. This is a term which is used for when you have a concentrated salt solution, that is known as brine. B-R-I-N-E. Now what are the ions present? So we have sodium ion, and we have chloride ion, we have hydrogen ion and hydroxide ion. So the ions which we have sodium ion, we have chloride ion, we have hydrogen ions, and we have hydroxide ion, OH ion. Now what is the movement of electron? Because this is a positive terminal, negative. On the left hand side we have cathode, and on the right hand side we have anode. So cathode will attract the positive ion. Sodium and hydrogen both are attracted, but which ion will discharge for positive ion? So for positive ion, always the less reactive. Whenever positive ions are there, the ion which is less reactive. So for that you have to recall the reactivity series. And according to reactivity series, if I write, we have sodium, this potassium is there, sodium is there, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. So when we go down in this series, what happened? The reactivity decreases. So down the group, the reactivity is decreasing. So which are the two positive ions we have? We have sodium and we have hydrogen. Which is less reactive here between sodium and hydrogen when we compare? Which ion is less reactive, sodium or hydrogen? Down in this series, the reactivity is decreasing. So hydrogen is less reactive. So for positive ion, always the less reactive is able to discharge or collect it. So the hydrogen ion, sodium is also attracted, but hydrogen is able to move easily. So what is the half equation? At cathode, from negative terminal, electrons are coming and these electrons attract the positive. So when hydrogen ion is there, it will gain one electron and it turn into hydrogen atom. But because hydrogen existing as a molecule, so when two hydrogen ions are there, they will take two electrons and it will turn into a hydrogen gas. So whenever hydrogen gas is there, so what is the observation? Hydrogen is a colorless gas, so you will see bubbles or colorless gas. And because hydrogen ions are gaining electron, they're taking electron. So when these hydrogen ions are gaining electron, we call that as reduction. So this change is the gain of electron. So we also call that as reduction. Is it clear? The cathode side, cathode half equation. The meaning of a discharge means, Abdullah Sarfraz, as you can see, sodium ion and hydrogen ion both are there, which are attracted towards the negative terminal, but which ion discharge or which ion is collected? The ion which is less reactive. So when we compare the reactivity of a sodium with hydrogen, because hydrogen is less reactive, so this hydrogen ion is able to move easily and it discharge or collected at cathode. So when hydrogen ion gain electron, it turn into a hydrogen molecule. Is it clear? Any doubt till this point? The term discharge means collected. So hydrogen ion, the two positive ions which are present in the solution, one is a sodium ion, another one is a hydrogen ion. Because hydrogen ions are less reactive, so they are able to move easily and discharge at, what is H and OH? H and OH is water. Because H2O is a formula for water which consists of H ion and OH ion. These are the two ions present in water, H plus and OH minus. Now what happened? No, we don't, because water is not like hydrogen molecule. It's not a combination of hydrogen molecule. When you check the structure of the water, as we already discussed, that when we draw a covalent structure of the water, it's not like hydrogen molecule is there. Two hydrogen atoms are attached with oxygen from both sides. But when it break down, when the water molecule break down due to electricity, in what it break down into H plus and OH minus. Means one of the H is being removed. That's why it is H plus and OH minus. It's not, you don't write that water molecule break into H2 and O. If you write like this, that's wrong. Because water molecule dissociate or break down into ion, which is H plus and OH minus. That's why I write here that for water it contains H plus and OH minus, and for salt, because it is a sodium chloride, it contains Na plus and Cl minus. So the positive ion, we have sodium ion and hydrogen ion. So hydrogen ion are less reactive, so they are able to discharge, and what we observe here, we'll observe a hydrogen gas is given off, so we'll see bubbles. Now what happened to negative ions? How would know if they'll form this? We have another compound, because as you Abdullah Sarfraz, can you use your mic? Your question is not clear to me.
Sir, I am telling like if we have another compound and the question is we have to separate it, how would we know that this will form and this will not form?
How you will know? You will always for positive ion, because you have always two positive ion. Whenever you are doing electrolysis, either it will be a molten substance. For molten substance, there is only one positive ion and one negative. But when it is aqueous substance, it is always water will be H plus and OH minus, and the second will be the compound itself. So you don't have anything else. Either it will be molten or aqueous. Aqueous is there, so H plus and OH minus. So it will always be like this. Is it clear? Yeah, because it is aqueous. The term aqueous, it's from word aqua. Aqua means water. So it means it contains water, and concentrated sodium chloride means more salt is there. So positive ion, we check the reactivity. For negative ion, what we do? We check the amount. The ion which is more in the solution. So basically, there is a attraction. Chloride ion is attracted. OH ion is also attracted. But which ion will move? The ion which is more in the solution. So as we mentioned in the beginning, it is a concentrated sodium chloride. So the term concentrated sodium chloride, which ion is more? Cl ion or OH ion? Concentrated means more salt. If there is more salt, it means it contains more Cl. So which ion will move? The negative ion which is more. So in this case, the chloride ion is more in the solution, so that will discharge at anode, or that is collected at anode. Yeah, for positive ion, always less reactive, and negative ion, we check the amount. So the ion which is more in the solution will move. So what happened? What will be the half equation? At anode. So the half equation at anode, as the chloride ions are attracted towards the anode. So when there is one chloride ion, it will lose one electron and it turn into a chlorine atom. But when two chloride ions are there, they will lose two electron and it turn into a chlorine molecule. And whenever chlorine molecule is formed, chlorine is a gas. So what is the observation? We'll see a yellowish green gas. Because it is a rule, Abdullah Sarfraz, that for a positive ion, the rule is the reactivity. The less reactive ion is attracted easily towards the cathode. But for negative ion, the rule is the amount. The ion which is more in the solution is attracted easily or discharged easily towards anode. That's a rule which you have to learn for positive and negative ion. So yellowish green gas will be there, and what we call this change? We call this change as oxidation. Because oxidation is a loss of electron and reduction is the gain of electron. Now, the sodium ions, the hydrogen ions are attracted. So the hydrogen ions will not be there as they move out. And the chloride ions are also attracted and they also go out. So what happened to electrolyte? What will be the change in the electrolyte? The electrolyte contains the sodium ion and it contains hydroxide ion. So the electrolyte will turn into sodium hydroxide because there is one sodium ion and hydroxide ions. So they join together in the solution and it will form sodium hydroxide. Is it clear? Any doubt? Abdullah Khan, Abdullah Sarfraz, Nourish, Heather, Afreen, Basira. The electrolysis of aqueous concentrated sodium chloride. So for positive ion, you will check the reactivity, always less reactive, and for negative ion, you will always check the amount. The ion which is more in the solution will move towards cathode, except 3, sulfate, nitrate, and carbonate does not move. Another example, if we are doing electrolysis of concentrated potassium chloride. For the half equation, as you can see in this part, when hydrogen ion is attracted, it turns into a hydrogen atom. But hydrogen does not exist as an atom, it exists as a molecule. That is why when two hydrogen ions are there, they will take two electrons and it will turn into a hydrogen gas. Because the non-metal cannot exist as an atom, non-metal exists as a diatomic molecule. That's why we have to write two. Same thing here, when one chloride ion is there, it loses one electron and it turns into a chlorine atom. But when two chloride ions are there, they will lose two electron and it turn into chlorine molecule. So if we have another compound, we are doing electrolysis of concentrated potassium chloride. So when we say first, what are the ions present? It's a concentrated solution. The term concentrated solution, it will have more salt and it will have less water. So more salt means it contains potassium ion and chloride ion, and less water means less H and OH ions will be there. So when we use electrolytic cell for the electrolysis, anode and cathode are made up of platinum or graphite. So this is a positive terminal, negative terminal. What are the ions present here in the electrolyte? It contains potassium ion, it contains chloride ion, H and OH ion. I'm just drawing one for each, but there will be many ions. So there is a potassium ion, chloride ion, there is hydrogen ion and hydroxide ion. First, what happens, from a negative terminal, electron will come out. So the majority of the electron will be there on cathode. For positive ion, basically cathode attract the positive ion, so it will attract both. Both potassium and hydrogen ions are attracted, but which ion will discharge? For a positive ion, which is less reactive. So which ion is less reactive here? Potassium or hydrogen? When you check the reactivity series, which ion is less reactive? So again, hydrogen is less reactive. Yeah, that's right. The hydrogen is less reactive, so this hydrogen is attracted, basically discharge. Attraction is there for both, but hydrogen is able to discharge. Now what is the half equation? When hydrogen ion is attracted towards the cathode, it will take one electron and it turn into a hydrogen atom. But because hydrogen is a non-metal, so it exists as a molecule. So when two hydrogen ions are there, they will take two electron and it will turn into a hydrogen molecule. So what we will have, we'll have a hydrogen molecule here, and whenever we get hydrogen molecule, it is, the observation will be a colorless gas, or you can mention bubbles. And because it is gaining electron, so we call this change as reduction, which is a gain of electron. The equation, the anode half equation for negative ions, what we check? We check the amount. So we have chloride ion, we have hydroxide ion. Which ion is more in the solution? The ion which is more in the solution will move towards anode. So both ions are attracted, but which ion will be discharged depending on the amount. So which ion will move towards anode? So as we know, because it is concentrated solution, means more salt is there and less water. So the Cl ion, the chloride ion, are able to discharge at anode. So at anode, what happened? The chloride ions, they will lose one electron and it turned into a chlorine atom. But because chlorine is a non-metal, so when two chloride ions are there, they will lose two electron and it will turn into a chlorine molecule. And what we call this change? We call this change as oxidation. And what is the observation? What we will see, because chlorine is a yellowish green gas, so we'll say a yellowish green gas is seen at anode. And what happened to electrolyte? What will be the change in electrolyte? So as we know, hydrogen ions are being removed, Cl ions are being removed, and we are left with potassium and hydroxide ions only. So the electrolyte will turn into potassium hydroxide, KOH. Is it clear? This electrolysis of concentrated potassium chloride. Anyone having a doubt? Any question or a doubt till this point? Same way, if we do electrolysis of concentrated HCl. So we have concentrated HCl and we are doing electrolysis. So what are the ions present? It means we have more HCl and we will have less water. So the ions which are present, H plus and Cl minus, and water contain H plus and OH minus. For positive ion, we check the reactivity. The less reactive will move. And for negative ion, we check the amount. The one which is having a greater amount in the solution, that will be discharged at the terminal. This is anode, cathode. Now what are the ions present in this solution? It contains HCl and HNOH. But for positive ion, we check the reactivity, but you can see both are hydrogen, so it does not make difference as both are hydrogen. So any of the hydrogen and can move. So any hydrogen can move. It can be from hydrogen from Cl, or it can be hydrogen with OH. Because both are the same ion, so we don't have to compare directly. We can say the hydrogen will move. So what will be the equation or half equation at cathode? The hydrogen ions are attracted, they will turn into a hydrogen atom. So when two hydrogen ions are there, they will take two electrons and it will form a hydrogen molecule. So what is the observation? Whenever a hydrogen gas is given off, we'll say bubbles, or we can also say the colorless gas. So bubbles are there or colorless gas is given at cathode. What happened at anode? For anode, we have to check the amount, the one which is more. So which ion is more in the solution? It is a concentrated HCl, so it means less water and more salt. So which ion is more in the solution? Which ion is more in the negative ion more in the solution? That's Cl. So what happened? The Cl ion is attracted. So when one chloride ion is attracted, it will lose one electron and turn into a chlorine atom. When two chloride ions are there, they will lose two electrons and form chlorine molecule. Again, the observation, whenever you have a chlorine molecule, so what is the observation? It will be a yellowish green gas. So a yellowish green gas is there at anode. Now what happened to electrolyte? As you can see, one of the hydrogen is moved out and chlorine is moved out. So what we are left with HNOH. So HNOH means what? HNOH means H2O, or we can say water. So means when hydrogen ion and chloride ion are being removed, we are left with water. So when electrolyte is left with water, or electrolyte will have more water, so we will say that electrolyte will be dilute. The term dilute means, like example, if you have a solution, say you have a juice and you are adding water to it. So when you are adding water to a juice, so it means you are making it dilute. Say about the observation, Abdullah, you have to memorize these observations. You have to learn these observations. When hydrogen is there, it will be above colorless gas or bubbles, and when chlorine is there, it will be a yellowish green gas. So you have to learn these observations. Is it clear till this point? Anyone having a doubt or a question? So right now in this session, what we have discussed is doing electrolysis of concentrated solution. We start with concentrated sodium chloride, which is also called brine. Then we discussed electrolysis of concentrated potassium chloride. And at the last, we discussed the concentrated HCl. In the next session, we will discuss how to do electrolysis or what will happen when we do electrolysis of dilute solutions. Any question till this point?